Hello friends, polynomial part 4. First of all, I am taking a question from the same identity number 5th. Okay, the question is 2x square plus y square plus 8z square. 2x square plus y square plus 8z square. 2x square plus y square plus 8z square minus 2 root 2 xy and after that plus 4 root 2 yz plus 4 root 2 yz and then finally minus 8xz. Is a question. In this question, factorize. We are going to find factorize. It is expanded form of the term and we are converting into the form of factorize. Number of terms, first of all, we are counting total number of terms present here 6 and 6 terms, that means this is an identity which can be used here. Okay. 1, 2, 3, 4, 5, 6. So first of all, we are converting in this standard form of the right hand side of this term. Writing this identity x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz and plus 2zx. You can see here some terms are here negative, but in this identity all the terms are positive. So no worry about that. Whatever the terms are negative, we'll have to decide that whether the first negative or second negative or third negative. First of all, we are converting into the form of standard form and proper matching form of this right hand side term to that term. So the sign right. See, this is 2x square and 2x square if I want to write here in the form of whole square. So I have to write here root 2x whole square. Is it okay? Square of root 2, that is 2x square. Plus y square, no change as it is, plus 8z square. 8 can be written, which number we have to, I have to write there in the form of whole square of that number and the result is 8. So that number is 2 under root 2 z whole square. Or I can write here root z whole square also, 2 root 2. 2 2s are 4, under root 2 multiplied under root 2 it is 2, 4 2s are 8, 8z square. Minus 2 root 2 xy plus 4 root 2 yz and minus 8xz. Is it okay? A square plus b square plus c square plus 2ab plus 2bc plus 2ca or xy plus yz plus z. Anything we can write here. But here the problem is, if I analyze this term, then I'll get a result that this is 2 root 2 xy is a negative and 8xz is negative. These two terms are negative. That means here xy and xz, one term is common, that is x. So that means the term which are having xy and xz is negative. So out of these two terms the x is common. What does it mean? The conclusion is, out of these three terms, I think the first term x will be negative. Is it okay? X will be negative, then x multiplied by a positive, negative multiplied by a positive it is negative, and negative multiplied by a positive it is also negative. So what does it mean? The conclusion is the first term x is negative and y z positive. Or in other words, x is positive and y z negative. Anything is possible. So I am writing here x is negative and y z is positive. So that means x is negative, that means this is, may I write here, minus under root 2x whole square, no change in the meaning, plus y square plus 2 root 2z whole square minus, or I will write here plus 2 in bracket minus root 2x negative, y positive, plus 2 y. What is y? As it is, and in place of z, that is 2 root 2. 2 root 2 z. You can see 2 2s are 4 root 2 yz. This is 4 root 2 yz. And plus 2 minus 2 root minus root 2x and z. What is z here? Z means it is third term, 2 root 2 z. So I can write here 2 root 2 z. Now it is in the standard form. Let us check whether it is okay or not. First, second, third term are okay. Check from the fourth term. Plus minus minus 2 root 2 xy. Minus 2 root 2 xy. It is all positive. 2 2s are 4 root 2 yz. 4 root 2 yz. And third one is a minus sign. So obvious outside there is a minus sign. 2 2s are 4 and root 2 multiplied by root 2 it is 2. 4 2s are 8 xz. 8 xz. And what is this meaning? First term is minus root 2x, second term is y, and third term is 2 root 2z. So this extended form can be written in the form of first term plus second term plus third term whole square. That means I can write here minus root 2x plus y plus 2 root 2z whole square. And what is the meaning of this term? Minus root 2x plus y plus 2 root 2z, and in the second bracket also minus root 2x plus y plus 2 root 2z. That is one. Or in other words, I can write the answer root 2x minus y minus 2 root 2z whole square. Because when I take minus sign common here, minus 1 whole square, it becomes plus 1. So both the terms are possible. Either the answer is minus root 2x plus y plus 2 root 2z whole square, or the answer is root 2x minus y minus 2 root 2z whole square. Both the terms are same. So this is the use of identity number 5. Now I am taking next identity number 6. That is x plus y whole cube. X plus y whole cube. What is it? X cube plus y cube plus 3xy in bracket x plus y. Next identity number 6. This is x plus y whole cube. The meaning is x cube plus y cube plus 3xy in bracket x plus y. This is identity number 6. And 7th one is with the minus sign. X minus y whole cube, which is x cube minus y cube minus 3xy in bracket x minus y. This is identity number 7. So I am proving one of them. Suppose I am taking x plus y whole cube. X plus y whole cube. How this result is coming? This, let me tell you, x plus y whole cube. X plus y whole cube, that means it is x plus y, and of course third is also x plus y. Okay, and we are multiplying all three brackets one by one. So first x plus y remains as it is, and these two brackets I am multiplying x multiplied by x plus y plus y multiplied by x plus y. So that means it is coming x plus y, x square plus xy plus xy and plus y square. X plus y, after that x square plus xy plus xy, 2xy plus y square. Remaining two brackets are there. Again this x is multiplied to all the terms of the second bracket, and now the y multiplied to the second. So x multiplied by this is x square plus 2xy plus y square, and plus y multiplied by again x square plus 2xy plus y square. The result is it is x cube plus 2x square y plus xy square plus x square y plus 2xy square plus y cube. And that means it is x cube plus y cube plus 2x square y and plus 1x square y. It is 3x square y plus xy square plus 2xy square. It is 3xy square. So this is an identity. X plus y whole cube is equal to x cube plus y cube plus 3x square y plus 3xy square. Or other form, x cube plus y cube plus, if I take 3xy common, then it is coming x plus y. And this is the identity. So this is identity number 6, and same as if I take the minus sign here, then the 7th identity is coming like that. So these are two identities. Now I am taking some questions based on these identities. I hope you will prove x minus y whole cube, everyone. Multiplication of first two bracket, then whatever the result is coming to be multiplied by the third bracket and getting the 7th identity. Identity, both the parts will be used. Either you can use x cube plus y cube plus 3x square y plus 3xy square. This is also an identity. Now I am taking a question. Suppose a question is given and we are going to evaluate x minus 2 upon 3y, x minus 2 upon 3y whole cube. This we are going to evaluate. X minus 2 upon 3y whole cube. Let us see which identity is matching from this term. I think identity number 7 is matching. So first of all, I am writing this identity. X minus y whole cube is equal to x cube minus y cube minus 3xy in bracket x minus y. Here x is as it is x, there is no change. In place of y is equal to 2 upon 3y. Friends, one very important thing here, you are not going to write y is equal to minus 2 upon 3y. You know what is the reason? Because we are using the same identity, like this is x minus y whole cube. This minus sign is here, so that is also x minus y whole cube. So that means when we compare, the first term is compared by first, and the second, of course, it is compared by second without changing its sign. So x is equal to x and y is equal to 2 upon 3y, not minus 2 upon 3y. You can use minus 2 upon 3y. We are using this identity in place of that one, plus. So it's okay. So substituting the value here, it is x minus, in place of y, 2 upon 3y whole cube is equal to x cube as it is minus y cube. When I write the term of y, 2 upon 3y, so I think I should write in the bracket 2 upon 3y whole cube minus 3xy, x in place of y, again 2 upon 3y, and bracket x minus y, so x minus 2 upon 3y. This means x cube as it is, no calculation is required here, minus 2 upon 3y whole cube. When I open the bracket, 2 upon 3 whole cube, 2 2s are 4 2s are 8 upon 3 3 and 9 3 are 27. 8 upon 27 y cube minus, since this 3 can be cancelled by 3, minus sign as it is, 2xy, and in bracket x minus 2 upon 3y. And it means x cube as it is minus 8 upon 27 y cube multiplied inside when I open the bracket. So it is minus sign, 2 1s are 2, there are 2x, loss of exponents, the bases are same and power is 1 plus 1, 2. It is x square into y minus multiply by minus, it is plus 2 2s are 4 upon 3 x y square. So this is the extension form of this identity, evaluation form, x cube minus 8 upon 27 y cube minus 2x square y plus 4 upon 3xy square is the solution of this term. If I will take the second question of the same pattern, like 102 raised to the power 3. 102 raised to the power 3, and this question can be solved, or this value can be evaluated with the help of identity only, not multiplying 102 multiply 102 multiply 102. Then how to solve this question. See here, 102 to the power 3 can be written 100 plus 2 raised to the power 3. Using this identity x plus y whole cube, x cube plus y cube plus 3xy in bracket x plus y. Here x is 100 and y is 2. 100 plus 2 whole cube is equal to, in place of x, I can put 100 in place of y 2 and calculate it. So this is x cube, that means 100 cube plus 2 cube plus 3, 100, 2 and 100 plus 2. Okay, nothing I have done, only substituted in place of x 100, in place of y, that is 2. Then the result is 100 whole cube, 100 multiply 100 multiply 100. So that means it is coming 1 with 1, 2, 3, 4, 5, 6, 0 plus 2 cube, 2 2s are 4 2s are 8 plus 3 multiply by 2, 6 and 100. It is 600, 100 plus 2. This is coming 1 with 6, 0 plus 8. So 1 with 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 8 plus, if I open the bracket, it is coming 6 with 1, 2, 3, 4, 0 plus 600 multiplied by 2, it is 1200. And finally, when I am going to add all these terms, so the addition will be done like that. See, 1 with 1, 2, 3, 4, 5, 0, 5, 0, 8 plus 6 with 4, 0, 1, 2, 3, 4, 6. Writing should be done from the right hand side term, and 1200, 0, 0, 2, 1. And when I add them, then the result is 8, 0, 2, 1, 6, 0, 1. 1061, 1061, 208, 208. That is the answer of this question. That is 102 raised to the power 3. Okay. Another example I am taking when the expanded form is given and how to convert into the form of factor. Expanded form is given and convert into the form of factor. Expanded form is, here I can take a question. Here I am taking a question, and the question is 8a cube plus b cube, 8a cube plus b cube, 8a cube plus b cube plus 12a square b plus 12a square b and plus 6ab square. This is a question, and factorize. I told you only two types of questions are there. First, either evaluate or factorize. If the term is in the form of extended, we have to factorize. Term in the form of factorize, we have to evaluate. And use it with the identities only. So that is a question. 4 terms are there. You can see that all the terms are positive. That means it is matching with identity number 6, right hand side term. If I open the bracket, so it is 3x square y plus 3xy square. 4 terms are there. I am writing identity x plus y whole cube is equal to x cube plus y cube plus 3x square y plus 3xy square. Okay. This is a question. 8a cube plus b cube plus 12a square b plus 6ab square. And I want to match properly to the right hand side term on this. This means x cube. How to write this term in the form of whole cube? Because it is 8a cube. 8 can be written 2 into 2 into 2. 2a whole cube. So in place of 8a cube, I can write here 2a whole cube plus y cube. That means it is b cube. No change in it. Plus 12a square b and plus 6ab square. I am not going to disturb these two terms. Will remain as it is. In the next term, it is confirmed that in place of x there is a 2a, in place of y it is b. So I can write here 2a whole cube plus b cube plus. This term I want to write 3x square y. 3, what is x? It is 2a. And what is y? It is b. Plus 3ab square. 3x. X means 2a. And what is? X means 2a. And b square. B, that is, of course, b square. Now let us check the terms are correct or not. 2a whole square. It becomes 2 to the 4a square b. 4 3 is 12a square b. 12a square b with plus sign. Now let us check this. 2 3 is 6ab square. 2 3 is 6ab square. And now it is clear that the first term x is 2a and second term b is y. So this term, extended term, can be written in the form of x plus y whole cube. That means I can write this 2a plus b whole cube. Factor term. And 2a plus b whole cube, what does it mean? 2a plus b, 2a plus b and 2a plus b. These are the factor term of this term. So that is one. Second question I am taking here having some negative terms in it. Now again the question is factorize. And the question is 27 minus 125. 27 minus 125a cube minus 135a and plus 225a square. Again, using an identity. Here in the extension part, you can see that some terms are negative. And what does it mean? We are using this identity. So I am writing the identity x minus y whole cube is equal to x cube minus y cube minus 3x square y, and minus minus it is plus 3xy square. You can check it. 1, 2 negative sign. Here there are 2 negative sign and 2 signs are positive. Okay. Here x is equal to, but before writing x is equal to, I am writing this term in a proper form. 27. 27 can be written 3 cube minus 125a cube. 125. 125 is, this can be written 5 into 5 into 5. So may I write here minus 5a whole cube minus 135a as it is and plus 225a square. No change in it. Now in the next step we are going to change it, because now it is clear that in place of x there is a 3, in place of y it is 5a. 3 cube minus 5a whole cube minus, this I am writing here, minus 3x square y. 3 as it is, x square. What is the value of x? That is 3 square, and y is 5a. 5a plus 3xy square. 3, what is x? X is 3, and y square means 5a square. Now let us check. 3 3 is 9, 15 9s are 135a with minus sign, and here is 5 5 is 25, 25 multiplied by 9, 225a square. And it means this term can be written x minus y whole cube. That means 3 minus 5a whole cube. And 3 minus 5a 3 minus 5a, and 3 minus 5a. These are the three factors of this term. Okay. Now, next identity I am taking, that is first I'm going to verify x cube plus y cube is equal to x plus y in the first bracket and x square minus xy plus y square. Okay. So two more identities I am writing here. One is x cube plus y cube and second x cube minus y cube. Identity number 8, that is x cube plus y cube. X cube plus y cube is equal to, this identity I am writing in the factorized form. So factorized form is x plus y, x square minus xy plus y square. There's a plus sign, the plus, here is a minus, ninth. X cube minus y cube. First bracket x minus y, second x square plus xy plus y square. Again, the proving is the same as if you are going to verify this. So we'll have to multiply this bracket, x plus y multiply to this, you are getting the result. Okay. Let us check one of them. I am proving identity number 9. 9 is to be verified. X cube minus y cube is equal to x minus y, x square plus xy plus y square. Friends, nothing special in it. There are two brackets. Simply multiply first bracket by the second bracket. Here, right hand side term, x minus y, x square plus xy plus y square. First bracket of first number or first term, x square plus xy plus y square minus y, x square plus xy plus y square. After that, x cube plus x square y plus xy square minus, when I multiply by y to x square, it is x square y, it is minus x y square, and there's a minus y cube. And now you can see two terms, they are same but opposite in the signs, like x square y and x square y, opposite sign, xy square opposite signs, they are cancelled. Result is x cube minus y cube. So x cube minus y cube is equal to this. Same as we can prove it, this also when I multiply both the brackets. Okay. So friends, now using these identities and solving some questions on the basis of these identities, I am taking a question that is 27y cube plus 125z cube. Question is 27y cube plus 125z cube. This is a question and we are factorizing this term. Factorizing x cube plus y cube, x cube plus y cube. For factorizing, identity x cube plus y cube is equal to x plus y, x square minus xy plus y square. This is an identity and the question is factorized. X cube plus y cube. First of all, we are converting into the proper standard form. 27y cube plus 125z cube. 27 can be written 3y whole cube, 3 3 and 9 here, 27 y cube plus 125. 125 can be written 5z whole cube. And now you can see clearly they are matching. First term a cube plus second term b cube. Right hand side term, substituting the value here, x is equal to 3y and y is equal to 5z. to be substituted here. So it is coming 3y whole cube plus 5z whole cube is equal to x plus y, 3y plus 5z. In the second bracket, x square that means 3y whole square minus xy, 3y, y 5z, and plus z square, y square, 5z whole square. So it is coming 3y plus 5z. When I open the bracket, 3 3 is 9 y square minus 5 3 is 15 yz and plus 5 5 is 25 z square. So friends, these are two factor, 3y plus 5z 1, and second is 9y square minus 15yz plus 25z square. It is the second. Okay. One last identity is coming here, that is x cube plus y cube plus z cube minus 3xyz is equal to, in the first bracket, x plus y plus z, and in the second bracket, x square plus y square plus z square minus xy minus yz minus zx. So that is x cube plus y cube plus z cube minus 3xyz is equal to, in first bracket, x plus y plus z, and in second bracket, x square plus y square plus z square minus xy minus yz minus zx. And here one more thing I would like to tell you, if x plus y plus z is equal to 0, if x plus y plus z is equal to 0, then you can see this identity. If I will put here 0, so 0 is multiplied, this entire term becomes 0. So that means the identity is x cube plus y cube plus z cube is equal to 3xyz. But this is a very specific case. It is used only when x plus y plus z is equal to 0. Then we can use this result directly. Okay. So that is the identity, and here also this identity, there are two brackets. This bracket is multiplied by x. So second, the same bracket is multiplied by y, and third by z. After that we are getting this result. So we'll try to multiply both the brackets. I hope you are getting the result. Okay. I am taking a question. First, I will multiply this and prove this identity number 10 in front of you. X plus y plus z, direct I am multiplying this. Okay. These two terms I have taken and finding the result. So with x multiplied by this entire term, x square plus y square plus z square minus xy minus yz minus zx, plus second term y, again multiply by the same term, and third with z multiplied by the same term, xy minus yz minus zx. After multiplication, this is x cube plus xy square plus xz square minus x square y minus xyz minus zx square. These are the multiplication of x, plus now multiplying with y to the whole terms. So x square y plus y cube plus yz square minus xy square minus y square z and minus again xy z, plus third term multiplied by z, x square z plus y square z plus z cube minus xyz minus yz square minus z square x. And friends, you will see that x cube plus y cube plus z cube, these are the three terms. And one more thing, minus xyz minus xyz, and this is minus xyz. X cube plus y cube plus z cube minus 3xyz is left. Other terms you can see they will be cancelled. How they will cancel? Xy square with plus. Now you will see that xy square with minus. Xz square with plus and xz square with plus and xz square with minus. Cancel. Minus x square y plus x square y plus yz square minus yz square minus y square z plus y square z, and this is x square z with plus x square z with minus. So you can see all the terms cancelled except x cube plus y cube plus z cube minus 3xyz. So that means when you multiply these two brackets, you are getting this result. So this is an identity. Now on the basis of this identity, I am proving a question. This is the verification, but generally the questions are asking from this supplementary part of this identity. Suppose the supplement part of this identity, a question is evaluate minus 12 cube plus 5 cube and plus 7 cube. Question is evaluate using an identity. Simply, if the question is coming in front of you, then how will you start solving? You will simply multiply minus 12 3 times, 5 3 times, 7 3 times, and you are going to add and subtract it and finding the result. But clearly it is instruction that you have to solve or evaluate this question by using an identity. Okay. So first of all, we will understand and check it. These values x, it is x, it is y, and here is a z. Since the condition is given if x plus y plus z is equal to 0, then we can write here x cube plus y cube plus z cube is equal to 3xyz. So let us see. Let a is equal to minus 12, or here it is x, so I am taking here x. X is equal to minus 12, y is equal to 5, and z is equal to 7. These are three values given: a x minus 12, y 5, and c 7. X plus y plus z. If I put the value x minus 12 plus y 5 and plus z, it is 7. Plus 5 plus 7, it is plus 12 multiplied by minus 12, result is 0. And if result comes 0, what does it mean? If this term is 0, that means we can write in this form. So therefore, x cube plus y cube plus z cube is equal to 3xyz. So that means x is minus 12 cube plus 5 cube plus 7 cube is equal to 3x minus 12, y 5, and z it is 7. You can see that there are 4 terms. Only one term is negative, so minus sign is out. And after that, 3 multiplied by 12 multiplied 5 multiplied 7. So 12 3 is 36, multiplied by 7 5 is 35. 36 multiplied by 35. 6 5 is 30, 3 5 is 15, 3 18, 6 3 is 18, 1 3 is 9, 1 10, 0 16 2 1, 1 2 6 0 with minus sign because there is a minus. So friends, the result of this term minus 12 cube plus 5 cube plus 7 cube is equal to minus 1260. But you can use this identity only, first of all, you will check it whether the sum of these three terms is equal to 0 or not. If it is 0, then simply we can put 3xyz. But if it is not 0, then this long method like the cubing of first term, cubing of second term and cubing of third term, and after that we will calculate. Okay, but when we are using an identity, then definitely whatever the three terms are given, their sum will be 0. And if the sum comes 0, then we can use this identity. Okay friends, so this is the end of this chapter polynomial. I hope you have understood everything, and whatever the questions left in the NCERT book, you will solve them. And if you are having any problem, then I am available. You can ask me a question. Thank you.